In this lesson, we're going to learn about the Pythagorean theorem, and then we're going to discuss the converse of the Pythagorean theorem. So let's start first of all with a right triangle like so. And let's just make sure that we have the names of the different parts of the triangle down. So this side that's opposite the right angle, we're going to call the hypotenuse. And the other two legs we are going to call legs. So this is a leg and this is a leg. And so what we want to do now is we want to discuss what the relationship is between the lengths. Now we're not going to prove this right here. We're just going to talk about what the theorem is and what the converse is and how we use them. So the leg, I'm going to assign a variable to this, and we're just going to say if a leg is A, and this leg right here is B, and the hypotenuse is C, then the big idea here is that A squared plus B squared will always equal C squared. So the leg squared plus the other leg squared will always equal the hypotenuse squared. Alright, so if a triangle is a right triangle with legs A and B and hypotenuse C, then A squared plus B squared equals C squared. So that's what the theorem says right there. So if we were to just put a triangle out here like this, we're going to use a real famous one here. We're going to say this side is 3. We're going to say this side is 4. How do you find this side right here? Well, what you do is you say, okay, well, this is a leg and this is a leg, so that's this part and this part. So 3 squared plus 4 squared has to equal, and I'm going to call this C, so C squared. So 3 squared is 9, plus 4 squared is 16. That is equal to C squared, so 25 equals C squared. I'm going to find the square root of this to figure out what C would be, and the square root of 25 is 5. So it turns out that the length of this side would be 5. Alright, and that is a really famous combination there, 3, 4, 5. We call that a Pythagorean triple. You can double this to get 6, 8, 10. Double it again. You can keep going. All of those are Pythagorean triples, which especially these two right here are really handy to kind of memorize and get to know. So what we're going to do now is we are going to look at the Pythagorean theorem and its converse. So what we're going to do is we're going to take the Pythagorean theorem here and we're going to mark it up and write the converse of it. So basically for the converse, we take what's in the then part right here, and so it would say something like, if A squared plus B squared equals C squared, then, and we're going to take this part right here. I'm just going to shorten it. Then it is a right triangle. Okay, so the idea here is that we can take any old triangle like this. Let's use the famous one that I just shared with you. Let's say this was 3, this was 4, and this was 5. And I don't know, let's use feet this time. So the question is this a right triangle? And to figure this out, what you do is you take the two shorter sides, so in this case it'd be 3 and 4, and and you square them. So 3 squared plus 4 squared. And we check to see if it's equal to 5 squared. So 3 squared is 9, 4 squared is 16, and 5 squared is 25. And 9 plus 16 is 25, and this is still 25. And so is this a right triangle? Why, yes, it is. So this is definitely a right triangle. I know that because 25 equals 25. If it turned out to be some other combination of numbers, like 10 equals 15, well, we know that's not true, so that would mean that it's not a right triangle. So let's take a look at a couple examples. If you look over here, the question is this a right triangle right here? And I believe this is supposed to be 20 here. So what I'm going to do is I'm going to grab the two shortest sides. So right here is 12 and 16. 12 squared plus 16 squared equals 20 squared. And I can do the math, and what I'll figure out is, in fact, that all of this added together is 400, and 20 squared is 400. So is this a right triangle? Yes, it definitely is a right triangle. Truth is, you didn't even have to do all that work, because if you remember what I was talking about before, about those Pythagorean triples, 3, 4, 5. So 3 times 4 is 12. 4 times 4 is 16. And 5 times 4 is 20. And so really that's just a Pythagorean triple, so you wouldn't have to do all the work. But the converse of the Pythagorean theorem does prove that this is in fact a right triangle. Over here on this side, let's take a look at this problem. It says that we're looking for area of this triangle. So area is half times base times height. Well, this is the height, but I do not know what this is, what the base is. So we need to use the Pythagorean theorem. Now, this is really key. What side is this? Well, that is the hypotenuse. So I'm going to call that C. I'm going to call this A, and I'm going to call this B. So 7 squared plus B squared equals 25 squared. And 7 squared is 49 plus B squared equals 25 squared is 625, and I have to subtract 49 and subtract 49, and over here then I end up with B squared equals, let's do some quick borrowing here, that's 6, and 61 minus 4 is 57, and that looks correct to me. And then if I find the square root of this, and the square root of this, square root of B squared is B, and the square root of 576 is 24. So this happens to be 24. Now, if I bring this over to here, remembering that this is the base, back in my area I have half times the base times the height. So half of 24 is 12. And 12 times 7 is 84, I believe. And that would be in square centimeters. So, quick review, we were talking about the Pythagorean theorem, and then we were talking about how you can use this to find side lengths, either leg or the hypotenuse. And then we talked about converse of the Pythagorean theorem and how you can use this to prove that a triangle is a right triangle or not.